Today's video describes more predictions that can be made by using Le Chatelier's principle. The collision reaction theory can be used to explain why Le Chatelier's principle works the way that it does. When concentrations of reactants are increased, there are more collisions that can take place between reactants, which will result in an increase in the forward reaction rate. If the product concentration increases, then the reverse reaction rate will increase. Eventually, a new equilibrium is established where the collision rate is faster overall because the system contains a larger number of particles. If there are more particles, then there will be more collisions and more reactions. If substances are removed, then there will be a decrease in the concentration, and this will result in a decreased reaction rate. Don't forget that removing or adding solids or liquids does not change the concentration of that substance. Temperature changes can also affect equilibrium if a chemical equilibrium equation has energy as a term on the product or reactant side. Heating or cooling a system will add or remove thermal energy. The equilibrium will shift in a similar way as when products or reactants are added or removed. In this example, energy is on the reactant side of the equation. If energy is added to the system, that will increase a term on the reactant side, the energy. This will result in an increase in the production of HCl. The amount of sodium sulfate is not affected by the change in thermal energy because it is solid. In this example, the reaction is exothermic. This means that the energy would be a term on the product side. If energy is removed from the system, it means that a product is being removed. To compensate, the equilibrium will shift to the right to produce more energy. As a consequence, there will also be an increase in production of sulfur trioxide. Pressure and volume can also affect equilibrium of systems. This is considered when the reagents are gases. The two values of pressure and volume are related. If volume of a container is increased, then the pressure of the system will decrease. A change in pressure or volume will result in an attempt to restore equilibrium by creating more or less moles of gas. When pressure and volume are changed, we will need to consider the number of moles of gas. In this example, the volume is increased. This means that there will be more space for gas to form. The side with more moles of gas will be favored. The reactant or left side has 3 moles of gas, and the product or right side has 2 moles of gas. Equilibrium will shift to the left. If pressure is increased as a result of a volume decrease, then the system will shift towards the side with the smaller total chemical amount. In this example, because the pressure is increased, the side with the fewer moles will be favored, and so equilibrium will shift to the right. Catalysts do not affect the position of equilibrium, though they do reduce the amount of time required to reach equilibrium. Please review this table that summarizes how a system will respond when changes are imposed. This lesson marks the end of our chemical equilibrium unit. We will continue to build on these concepts throughout our next unit on acid-base equilibrium.